Okay, we're going to talk about moments. You're going to do probably about a page worth of notes. I'll tell you exactly what to write. We're going to do a couple introductory things and then basically 3 problems, each one progressing and getting just a little bit more difficult. All right, let's do this. We've talked about moments a little bit before, back when we were talking about machines. It's a fancy way to talk about rotation. So let's get a definition. Moment is basically right here, the tendency of the force to rotate. Tendency of a force to rotate. That's really all moment is. Oh, also, as I go through this, just remember you can pause. I am going to be talking faster than I would probably teach in class. Let's get our equation. And moment is force times distance. They like to say distance times force. I think it just kind of falls out of my mouth a little easier when I say force times distance, so I'll always refer to it as that. Moment is force times distance, and please remember it is a perpendicular distance. Force and the distance is perpendicular. Please make a note of that in your notes. Moment is force times a perpendicular distance. This table is important. Let's jot this down while I talk through it. You'll see we'll probably use both of these units in class, the English and the SI units. So our force is pound force or newtons, and feet or meters. So our answers will be in pound feet or Newton meters. Rotation is important. A lot of the times we're talking about a bridge or something that's in static equilibrium, meaning that it's balanced. So one moment has to balance another moment. What we need to know is CCW stands for counterclockwise. So counterclockwise is positive, clockwise is negative. That's really important to remember. They talk about this right-hand rule. Let me show you real quick. I think it's just easier to remember, and you'll get it with enough practice. So you notice in that last slide, notice the direction that the wrench is rotating. So if you curl your right hand, you curl your fingers in the direction of that red arrow, notice where's your thumb pointing? Should be pointing up towards you. So that would be a positive moment, and then the reverse or the opposite would be negative. You have to kind of turn your arm around so your thumb's pointing away. That's a negative moment. So that's another way to remember it. Let's get into our first example, which is going to be this one. Let's make a quick sketch of little wrench, the distance, and the force. Draw that with the arrow, and please make note that this is a negative force, or excuse me, a negative moment. Please show your equations, substitute and solve. We have 9 inches over 0.75 feet, and remember, negative moment, so we stick that negative right there, right off the bat, so we don't forget. Negative 20 pounds, 0.75 feet, negative 15 foot-pounds clockwise. Go ahead and finish that up. Pause if you need to. This just shows, don't write anything down for this one. This just shows I have a longer distance, so what should you expect with the moment? You should expect that to increase, right? And these are just showing some different applied forces, and don't forget that force, or excuse me, moment is force times a perpendicular distance. So in this case, do we care about this 1 foot? We actually don't, right? So force times distance, here's our 20 pounds, negative, why negative? It's going clockwise, right? And 0.25 feet away from its point of rotation. Same with this goofy looking wrench. Which distance do we care about? Think about that for a second. We just care about its overall distance. And then we're going to have, looks like a negative moment of 30 pound-feet. We're going to skip over this one for now. We'll come back to that a little later. And so that's your first example, that little wrench. And your second one is coming up right here. Let's make a little sketch of a seesaw. You're actually not going to draw the bears on it. Notice that the bears are going to get They're going to get replaced in just a second. And look at what's happening. Obviously the heavier mass or the heavier bear is going to make the seesaw imbalanced, but what happens if that one bear or that one force scoots over? It can be balanced and it can be in static equilibrium. So they're going to replace them with these arrows. Let me get all this stuff up here before you start writing. There you go. So go ahead and draw your forces, your arrows. This 25-pound force is rotating counterclockwise, right? So it's going to be a positive moment, and then this one over here is going to be a negative moment. Here are distances, and looks like we're trying to find this D2. Okay, now that you're done with your picture, let's start up here. Sigma stands for the sum of. Like the sum of 2 and 2 is 4. The sum of 3 and 5 is 8. So the sum of the moments has to equal 0. So we have 2 moments, moment 1, moment 2, and they must equal 0. Easy as that. So we have force times distance, and force times distance equals 0. Ignore, let's ignore this little part right here. Yeah, don't worry. Don't worry about this part. Don't worry about this part. Yeah, it's basically sum of the moments equals 0. Moment 1, moment 2 equals 0. Easy as that. Moment 1, we have 25 pounds of force over 4 feet. And then it might want to write it this way so it doesn't confuse you. Then you're actually adding a negative, just like they had there. You're adding a negative 40 pounds times our unknown distance. All that equals 0, right? That's just like up here. The sum of the moments must equal 0. We had 1 moment, plus we're adding a negative moment, and that equals 0. When we do some algebra, we get 100 pound-feet, and we get, I can't do much here. This is kind of like combining 2 and x. What do you get? You get 2x, right? And what you'll notice, they didn't quite show it in the step. They took 40 pounds times our distance, brought it to the other side of the equation. When that happens, this negative went away. That's why we end up with equals, notice the negative is gone, 40 pounds times our distance. Now we're basically home free. We're solving for distance. Divide by 40, divide by 40. We get a distance of 2.5 feet. Okay, we're going to add a little step. This is your, get all the stuff up here. You had your little wrench example. Oops, too far. You had your wrench example, your bear example. We're going to do this one and one more. So squeeze these in. I bet you can do that on one page. Okay, similar idea. Let's kind of walk through your picture as you're sketching it. We have, these are reaction forces, so this is something new now. You know, Newton's law, whatever's pushing down has to be pushing up. We'll pretend this is like a bridge, and we don't want it to move. So our birthday present weighs 35 pounds, that's heavy. Point A, point B, point C. We have some distances, and we have an unknown force here, and actually an unknown force here. Okay, so look what hasn't changed. The sum of the moments still equals 0. Let me switch to my pen. I might have to write something down. Sum of the moments equals 0. Moment B plus moment C equals 0. Okay. I actually like to start from point A. This is our, remember, this is our point of origin, or point 0, 0, our point of rotation. And I actually like to order it as I walk across this bridge. I kind of pretend I'm walking across the bridge. So I would order it moment C plus moment B equals 0, but it doesn't matter. You might be asking, well, why don't we have a moment at A? Well, think about it. Force times distance. You have a force right here, but what's RAY's distance from itself? 0. Anything times 0 is 0, so that's why you only see these 2 moments. All right, moment B plus moment C equals 0, and off we go. So here's our distance for moment B is 10 feet, and times an unknown force, so force, distance, right? Plus, let's say moment C, That is 3 feet, and oh, good, they put our negative 35 pounds. So 35 pounds over the course of 3 feet, and all that equals 0. And we can combine some stuff. We end up with negative 105 equals 0. When we bring that 105 to the other side, it turns positive. This should be familiar. It's just like our previous problem. And now we can solve for RBY by dividing both sides by 10. And we end up with RBY is 10.5. So now we can go one step further. Boy, if we know that this is 10.5, and I know this is pushing down 35 pounds, Newton's law, action, reaction, well, heck, I mean 35 minus 10.5, RAY has to be 24.5 pounds. Okay, we're going to do one more. Let's talk about, notice between these two, we've changed these forces with what are called a pin and a roller. Watch how it changes. The icon is usually a little triangle, and then a triangle with some wheels on the bottom, or some circles. And it's literally a roller. Think about a steel bridge in the summer. What happens to metal, or actually most anything when it heats? What happens to its size, right? It expands. So this bridge needs to be able to expand this way. I'll explain that in a second. And what you're actually going to draw, let me get everything all loaded up. That'll work. So these are reaction forces. So this big beam where my pointer is, let me change this so you can see it better. This beam where my little pointer is pushing down on point A. It's pushing down on point D, right? Well then, the roller on this side has to push up, and the pin on this side has to push up. That's easy. This is a pinned connection. It's bolted in. It can't move any way. So if I'm pushing, watch the direction of my arrow. If I'm pushing this way, well, the pin itself is pushing back. It's pushing down. The pin is pushing up. Notice there isn't another another reaction force in the X direction on the D side, because I said it was a roller. It is free to move this way. That's why there's no reaction force pushing it back. And I'll explain this more in class. So we have our reaction forces. We have a 500-pound load, a 600-pound load. Let's do some math. Okay. Oops, make sure I had everything pulled up. Okay. Sum of the moments needs to equal 0. Nothing's changed. B, so it's clockwise, right? Negative moment. C is going to rotate counterclockwise. Let's see. That's why it's positive. Oops, little typo. Let me fix that real quick. All right, I'm back. Let me start that over again. I just had to add something real quick. Okay, here we go. Point B, negative moment. Point C, also negative moment. And D, counterclockwise or positive moment. Sum of the moments must equal 0. And force times distance, force times distance, force times distance. That's all we're doing. So let's do B first. It's 12 feet. Remember, perpendicular distance times negative 500 pounds plus 24. This is moment C. 24 feet, right? Times 600 pounds, negative 600 pounds. And then we don't know RDY, but we do know it's 32 feet away. So 32 RDY. All of that equals 0. Now we can simplify some things. We're getting closer to being done. And I can simplify negative 6,000 plus negative 14,400 equals negative 20,400. And nothing changed here, plus 32 RDY. If I bring negative 20,000 over to the other side, that will become positive. Sorry, one more typo. Let me fix that. Okay, sorry about that. I fixed it. We were on this 20,400. You bring it to the other side, it becomes positive. And this is the same thing as writing, like, 2x equals 4, right? Do some algebra, divide both sides by 32, and you are home free. So you should have a basic idea of moments now. Please make sure you ask your teacher if you have any questions, or if there's anything you need to that needs to be clarified. This can be a little daunting at first. Again, follow these steps and you will be just fine.